Welcome friends, this video is brought to you by MatMock.in. It's Simple.Point.Click.Learn. Today's topic is Introduction to Linked List. So the objective of this lesson is what is linked list. Then second we will learn need of linked list. Then we will see advantages of linked list. After that we will see basic operations on linked list. Then we will see types of linked list and the lecture will be over. So starting with the very first topic, what is linked list? So the diagram which you are seeing on the screen is called as a linked list. Linked list consists of different nodes. The particular this one thing is called as a node. Okay, so how many nodes are there? This is one node, 2, 3, 4. There are total 4 nodes. Each having two different parts. One part is called as data part and another part is called as pointer. So what is linked list? Linked list is a linear collection of data elements called nodes, each pointing to the next node by means of pointers. Pointer is a variable which stores the address of another variable. Same is the case here. Here the first node is pointing to second node by using pointer, means it is storing the address of second node, and second node is storing the address of third node is storing the address of fourth node, and fourth node, here the list ends, hence it is storing null instead of storing any address, means it is not pointing to any other node, that is indicated by null pointer. So after this I think you got what is a linked list. Linked list is a linear collection of data elements. Okay, what here in the diagram 10, 20, 30 and here you say it as 40. Okay, this is data element. So linked list is a linear collection of data elements called nodes, each pointing to the next node by means of pointers. Now we will see why we require linked list. Okay, linked list overcome the drawback of an array. What are the drawback of array? In array, if the memory is if all the array is full, then we cannot add new element in the array. If you have already allotted array of size 1000 and using only 2 memory location, then rest of the 998 memory location of the array will be wasteful. Okay, so these are the drawback of array. Apart from that, there are 2 more drawback of an array, like insertion in the array is difficult, and also the difficulty in the array is also deletion of an element from array is difficult. So linked list overcome this drawback of an array. In linked list, number of element need not be predetermined. More memory can be allocated and released during processing. This process is called as dynamic memory allocation. Insertion and deletion are easier to make, as we have already discussed. Then we see why do we require the linked list. What is the need of the linked list? List. First we will see what is a list. List is a term used to refer to a linear collection of data items. Suppose you are going to the market, you will have shopping list. Suppose you are enrolled to a college, then you will go to roll number and the teacher will have roll call list. So list is a term used to refer to a linear collection of data items, like days in a week, Monday, Tuesday, Thursday. So they are a linear collection. Months in a year, again a linear collection. So that is a list. That term is called as list. A list can be implemented by using array or linked list both. Array can also be used to store the sequence of your roll number. Array can also be used to make a list of your shopping, like shopping list can be maintained with the help of array. You already know that. But the same thing can be done with the linked list also. In arrays, there is a linear relationship between the data element, means one data element will follow another data element. From an array, any of the element can be accessed easily. Like for example, you want to access fourth number in the fourth element in the array, you can very well access by using a of 4. Okay. So in arrays, there is a linear relationship between data elements. From an array, any of the element can be accessed easily, but it is very difficult to insert and delete an element from an array. Why it is very difficult to insert and delete an element from an array? Imagine an array containing 1000 elements and you want to insert a new element at the location index number 2. Now what will happen? If you are inserting new element at the index number 2, then the data element which already exists at index number 2 should be shifted to index number 3. 3 will be shifted to 4. 4 will be shifted to 5. In this way, each element will be shifted till the last. What is the last element? 1000. Okay. So it is very difficult to insert an element. To insert an element, you require to shift 998 elements. Right. Same is the case when you are going to delete an element. If you are deleting an element from an array, then particular number, say index number 2, will be deleted. It will be removed and index number 3 will be shifted to 2, 4 will be shifted to 3, 5 will be shifted to 4. In this way, 998 times you require the shifting of elements. So it is very difficult to insert an element and delete an element from an array. Also, a large block of memory may be allocated to an array which may be not in use. For example, you are already declare an array of size 1000, but you are using only to store the 2 elements of the array. What about 998 blocks of memory allocated to array? That is totally wasted. So there is wastage of memory when you use array to store the list. It is also difficult to increase the size of an array. Suppose you don't want to waste the size of the array, then what you do? You take the size of the array as 5. So 6 element can be stored from 0 to 5. Now what will happen? If 7th element comes, you are unable to store the element in the list. So it is very difficult to increase the size of array if required. In order to overcome these drawback of an array, we can store a list in such a way that each element in a list contain a field called link or a pointer. Okay, each element will contain one more field. Okay, that will called as link or pointer, which contain the address of the next element in the list. Okay, so the first element itself will tell where the next element is stored. Okay, so also note that the successive element in the list need not occupy the adjacent space in the memory. Okay, this is also one of the advantage of the linked list. So why you require the linked list? In order to overcome the drawback of an array, we store a list in such a way that each element in a list contain a field called link or pointer, which contain the address of the next element in the list. Okay, so to overcome the drawback of an array, you require linked list. Then we will see the advantages of linked list. The drawbacks of the array are overcome by the linked list. So these become the advantages of linked list. Following are the advantages of linked list. Number 1 is linked list can allocate memory during execution of program. No need to allocate the memory before execution of program. Okay, so this is the first advantage of linked list. Right. Then efficient memory utilization. Memory is not pre-allocated like array. Then insertion and deletion is easier in linked list. Linked list does not require contiguous memory. Contiguous memory means continuous memory. Okay, so that is not the requirement of linked list, because as and when the memory is required, you are allocating memory only for a particular node, and you require the address of that node. That address will be stored in the backside node. Okay. So enough we have discussed about linked list. Now we will discuss basic operations which can be performed on linked list. As you know, in every data structure we perform different operations on that particular data structure. Say for example stag. In stag we can add new element or remove an element. That particular operation is called as push and pop. In queue also we add a new element and remove an element. So in linked list also there are various operations which can be performed. The very basic operation in the linked list is creating a linked list. Then we will see. Then inserting an element in the linked list. Then deleting an element from the linked list. Displaying or traversing a linked list. Counting the number of the nodes in the linked list. searching in a linked list, reversing a linked list, then sorting a linked list, and at last we can merge two different linked lists into a single linked list. Okay, so whatever the operations that can be performed on an array, those can be performed on linked list also. Okay. Okay, lastly we will see types of linked list. As you are seeing the diagrams on the screen, single linked list will have a single pointer, double linked list will have two pointers, like one pointer pointing to the next node and one pointer pointing to the previous node. Circular linked list, in circular linked list the last node will not have a null pointer. Instead of keeping a null, it will point again back to the first node. That kind of link is called as circular linked list. So we will see in detail how to perform insertion operation, deletion operation in single linked list, double linked list and circular linked list in our next video. Okay, till then keep watching and you will learn more about data structures. If you have any question, please write it down in the comment box. What you require to do is log in with the Google ID or your Gmail ID and you can review or you can ask any questions. Okay, if you want to review the question, then you can review. Thank you. Keep visiting our site MatMock.in. It's simple, point, click, learn.